What's neat about our project is that we combine this sort of abstract machine learning and modeling with real problems. Our watersheds are real places. In those places, snow falls on the ground. Snow melts, and that snow has to flow in to form these really small creeks. You look out over this landscape and you don't see any streams. Really what happens is the snow melts and it seeps into the ground. And it becomes groundwater, and then that groundwater comes together and the streams start to emerge out of the ground. And this is a very subtle process at first. And as you see, by the time we move just a short distance, we get these big meadows, then we start to form these mountain rivers, and then all of a sudden, boom, humans are there. And we've got big reservoir, and a human is pulling a lever or turning a knob to change what happens, influencing our water. So HydroGEN is important because it will provide new hydrologic data to decision makers who need it. And right now they're flying blind. They don't have the right tools to make the decisions they need. And it's not for future, it's for right now. Right now we are off the roadmap. We don't have a roadmap for how much water we're gonna have, where it's gonna be, where wildfires are going to be, whether we can pump groundwater for our food. We don't have that information right now. And we need better models, and we need them to be in the hands of the people who are making decisions.
I think one of the groundbreaking things about HydroGEN is that we can build these custom tools on the fly. In the past we've dealt with tools that are either national scale, and so they're not relevant for really local water management decisions, or they're too simplified because they've had to be in order to build them for a local application. So one of the amazing things about HydroGEN is that we meet that in the middle, and we solve the problem in the middle with the complicated models and the tools that you need to solve problems that are changing. We've seen fires in Colorado, for example, on the scale that we've never seen before, with the top 3 in 1 year. And so these landscapes are changing, and our water resources that come out of these landscapes are changing. So you need custom local tools to evaluate that quickly.
One of the big pieces about the HydroGEN platform is accessibility. I think a lot of these tools are very complex and the learning curve can be steep, and we really want to make these tools and make them highly usable and really efficient for people that want to access this type of information.
The water that we're looking at here today, just outside Las Vegas, Nevada, actually comes from more than 500 miles away in the Colorado headwaters. Currently, we're really limited in our ability to provide good information because we're really off the map here. What HydroGEN does is combine machine learning with observations and really advanced physical hydrology models so that we can take into account all of the complicated interactions that are happening upstream and provide better forecasts to users downstream.
This is HydroGEN. We are a team of
hydrologists,
computer scientists,
machine learning experts,
data scientists,
user experience specialists,
software engineers,
and educators.